Testing, testing. Great. Okay. Hello, everyone. My name is, as I was just introduced, I'm Ryan Peters. I'm a senior Scala engineer at ZBA Functional. And this talk is a lot of things, maybe too many things. I worry it's too many things, but we'll try and get through as much as we can because there's just so much I want to talk about. So this is sort of chronicling the feature-wise, functionality-wise, ecosystem-wise development of a side project of mine that has changed about 5 million ways over the past 6 or so years. Not to say I've been developing it for literally 6 years, but I've like rewritten it maybe multiple times over those years. And we're going to talk about what it is today and what the sort of things I've learned along the way about developing for Scala.js. So let's talk a bit about the actual project first. I don't know how well you can read that text, but it's called TinyDB, and it is an in-browser database-ish application that is written entirely in Scala.js. And you use it kind of like a spreadsheet, kind of like Excel, actually. In fact, that was the most direct inspiration. Is I wanted something like Excel, but a little different, closer to a database, where I could do things like joins and be able to use it on my phone in a more nice way. And the end goal is to just have a really nice general purpose tool for doing database-ish tasks on your phone, on your tablet, on your computer, anywhere you can run a browser. These are some features on the right. The only one of those that I haven't actually implemented for today is the reactive views, but I'll explain what that is later. So we're actually just going to hop right into a demo. Who likes fun live demos? I sure do. You know why? Because I finished a feature for this like literally 10 minutes ago. So, all right, okay. So this is literally running the latest debug filled, print line filled code that I just got compiling a few minutes ago. And by the way, this is super ugly. Like I never really polished this up much. It's the first thing you want to do here. So let's say you want a table. Let's just call it. Okay, what's a good use case? Something that I've been trying to use this for is managing my video game backlog. So let's just let's say make a games table. That sounds good. So you get a little tab here. You can delete it if you want, but we're not going to do that. You can add multiple columns here. You can delete the columns. You can rename the columns. So let's say let's call this one title, and we'll call this one platform. And I just want to list out all the different games I have. So let's start with a few rows. We can add rows one by one. I didn't choose a table layout. I actually wanted to use this sort of button-ish layout because I want the end goal of what I want this to look like is I want this to look kind of like you're editing an Excel spreadsheet. So you click on something, it seamlessly transitions to an input, and then you can add things there. So let's say a video game. Zelda, all of them, why not? And let's see here. System Shock and I don't know. Civilization. Those are video games, right? Somebody knows. And for the platform, we're going to do something a little different. So you notice I've been entering text here. One of the features that I wanted to have here is I want to have custom enumerations. So let's say we have a platform enumeration here. We can add values to the enumeration and say here, say this is a switch. This is some PC Steam. And this one is just PC in general. So now we can change platform here to a custom enumeration column, select platform, and just go crazy. So I'm going to lie and say that System Shock is only on Steam. And now the fun part, the actual reason that I wanted to do this in the first place is I want to run queries, and that's not something that's very easy to do with the web version of Excel. So we're just going to click this little query button right up here, and we're going to give it a name. So let's say filtered games. We can select a table, So we're going to say games. It does let you join with another table right here, but we're not going to do that just here. If we have time, maybe I'll show it off. There's a way to add aggregations, which is a whole thing. And then we're going to, we're actually just going to filter it. We're going to say where the platform column is equal to switch, and just run it. Oh, that didn't work. Why didn't it work? We're going to pretend that worked. Well, I'll get back to that in a minute, but it did work a few minutes ago. One thing that you can do also is this import from a CSV, and I have a ready-made Excel sheet right here for your pleasure, but we're just going to pretend I already exported it and paste it, where do we go? Over here. CSV. There we go. So that actually did work, and it just imported everything as it kind of goes off the screen a bit, but I'll fix that in later. This is super early buggy software, so it's not perfect yet. But one thing that I know does work because I just tried it. So let's make a new table here. Let's pretend that I have group bys working, because that's the one thing I didn't get working, besides the other thing that didn't just work. And we'll say we'll make a table for the count of games per platform. So we're gonna say this is the platform. That's basic, and we're going to put in count right here, and we're going to pretend that we have like a group by aggregation thing going on here. And we'll say this is PS1 games, this is Nintendo 64 games, and there's a million games for the PlayStation, so we'll just say I have like 10 of them. And Nintendo 64, we'll put 4. And we can turn this into a chart. So just like in Excel or other things, you can make charts. I only have pie charts working right now, but that's the feature I just got working like 10 minutes ago. So let's say game chart. You can select the column for the label and the column for the value. And that's a little big, but it is actually the values from the table, if you can believe it. And that did work. I'll give you one quick more look at the query thing again. So there's a whole parser in here. I'll have to maybe figure out later if something's going wrong with it or if I put in the wrong info. But the way this works is just like you imagine a relational database would work. You pick one table here, you can join it with another table, and it will actually figure out in real time what are the valid columns that you can select. And when you add an expression here, you just get multiples in a sequence like this. You can give them an alias. You actually have to give them an alias in this. And aggregations are separate from regular select expressions because of just trying to get the feature working. And they do require a little different information. So the only thing I have supported right now is count. So I don't know if I can get... I'm going to try this. It might work. If it doesn't work, then oh well. But if it works, great. We're going to select from that games table. And we're going to say we want to aggregate. Let's see here. Well, if I just say any column name, it'll be fine. Just say count platform, run query as count. Maybe this will work. Oh, that is not what I wanted to see. Well, there's a number 3 there. So yeah, it counted the number of rows. Normally you'd put like an asterisk there, but I haven't actually implemented the asterisk thing yet. So it just counted all the rows on this table and gave us a count. So aggregations, in theory, they work. Okay, so that's all the time I have for this specific demo. So we're going to go back to the slides and talk a little bit more about what exactly is going on here and how we got from point A to point B. So TinyDB has a whole bunch of different things going on under the hood. It's using the Tyrian library / framework for UI and state management. If any of you were doing the workshop that Jack and Rafa were doing, I believe that they used Tyrian for some of that. I've used FS2 data CSV for CSV parsing. So all of those first 2 things so far are just entirely Scala. So almost no JavaScript dependencies except for the charts. chart.js, and I'm using a CSS library called Bulma for the CSS. It's pretty boring. There's no JavaScript in it. So, is that the next slide? That is the next slide. Okay, so getting started. So I started using Scala and Scala.js back in 2017 or so, and it's a lot easier today to get started than it used to be. You can literally copy and paste this code right here. This is a slightly minified example from the Scala CLI webpage. I just tried it yesterday, so I know it works. If you run this here command on the right, and you run it in Node.js, then it will just print you a hello world. And that's about as easy as it gets to just run something in Scala.js or to just compile something. But now you might be wondering, if let's say you haven't used Scala.js, why would I use Scala.js? What does it give for me? So there's the main point of comparison, of course, is probably going to be TypeScript. There's other comparison points as well, but those are entire talks in and of themselves. So I'm going to just focus on Scala.js and TypeScript right here. So Scala.js, it's Scala. We all love Scala. That's why we're here. I would prefer to be writing Scala most of the time. There's a million features and a half that I want to use in Scala that are just not in TypeScript, like having good enumeration support. Enumeration support is just amazing in Scala, especially Scala 3 if you're using the new enum feature. The most of the Scala ecosystem actually already runs on Scala.js. It already compiles. It also usually sometimes works in Scala native as well, and that just means that all of your favorite libraries, you can use FS2, you can use Cats, you can use Zio, you can use anything, and it will just work in the browser as you expect it to. And that's great. And that helps you abstract over all the annoying parts of JavaScript as well. But the downside of that, of course, and this is unavoidable, is that when you're doing that abstraction, that means that you have to integrate with JavaScript on occasion. If you can avoid it, great, but whenever you have to, it's a little painful. TypeScript, on the other hand, it is JavaScript with types. So you just rename a file and it's literally TypeScript. It has really good structural type support, which is necessary because JavaScript is... Okay, the JavaScript ecosystem is filled with a lot of really weird type function signatures that are just really hard to encode in other languages because they're just... I don't like them. You know what I'm talking about, right? Like you'll have a function and you'll have to pass an object and it'll say, as long as it has like 3 or 4 of these 5 keys, you're fine. Like there's a million functions like that in libraries in JavaScript. So trying to properly type that is hard, and TypeScript does a very good job of it. Trying to map that to Scala is a little hard though. And that of course means that with TypeScript, you can just go down to just writing regular JavaScript if you have to. And sometimes that's the easiest way to get something done and just get it working and then move on with your life. But in Scala.js, it's not quite so simple. You have to have a little bit of boilerplate unless you try and generate, which I'll get to later. So yeah, get that the interoperability later is the main thing that has been the significant pain point, I guess, for me over the years. It's not because of a fault of Scala.js on its own. It's very good at this. It's excellent, actually. It's probably about as good as I could ever hope it would be, realistically. But there's just some things that you cannot do very easily without needing to either, put in a little elbow grease or you rely on some kind of generated code. And the way that these integrations work is through something called facades. A Scala.js facade is basically just a wrapper around one or more of these different layers here. So at the very bottom, you have actual JavaScript, the part that you want to avoid. Then you have the Scala.js runtime, which is abstracting on top of that. It figures out things like the type mapping. So for example, in Scala, you have ints. In JavaScript, until relatively recently, you didn't really have something that was a proper int. Most numbers are just numbers, which are equivalent to doubles. And things like, longs or characters, those are opaque types in Scala.js, and they have a custom implementation in the runtime to support working the same way that you expect them to in your Scala programs. And then you have these traits that you write, this like sort of foreign function interface here. You need these annotations that Scala.js provides to interop with JavaScript functions and say, okay, there should be a function here with a certain name, and it accepts values of these types. And then Scala.js, the compiler, will figure out what your code is supposed to be. And then at the very top, ideally, you have just regular old idiomatic Scala. So you can, in a good facade, a great facade, I would say, a great facade. A good facade can just get the job done with a basic wrapper, but a really good one is one that translates into something that makes you feel at home. It just lets you write Scala and lets you think in Scala terms and not need to mentally translate JavaScript isms into various things. So facade development kind of looks like this. Here's a small snapshot of the kind of thing you'd be doing. So you have a trait, you need to annotate it like this. You specify the values of the trait. This is something that represents an object in JavaScript. And what I'm saying is that there exists an object that has a shape that looks something like this. These types exist, or maybe they don't. In fact, there's the types right there are js.undef or. That's kind of like option, except not really, but it kind of is. You can convert back and forth. And what that means is that the key in the JavaScript object that you might be getting might not exist. And so the Scala.js compiler and runtime, it has functions to handle these types of situations. But when you are getting a value from a library, you can't just pretend that that value is always there. You can't say it's an option either, because options have their own semantics that might be a little bit different from this. So this is just some boilerplate in here that says, okay, this is specifically for JavaScript, something that might not be there. And now you say, okay, well, what if I have to pass one of these to a function? What if I'm passing a value that is shaped like this to a function? The easiest way that I found to do that, the most straightforward way, the way the docs say you should do it, and I wouldn't necessarily know if there's any other way actually, is just creating a literal object. So right down here at the bottom, there's this function here on the companion object to this sum type. And we are passing in a message. We're just going to ignore the error field because it could be undefined, so we don't have to define it. And we just create a literal object with this js.dynamic.literal helper. We pass in values kind of like a map, where the left side is the keys and the right side here, that is the actual value. The value does have to be something that maps to a type in JavaScript. So you can't pass a Scala list in there, I don't think. I think you have to convert it to an array or a mutable sequence first, for example. Or if it's a long, longs don't exist in JavaScript, so you have to just pick a number type that does exist in JavaScript and go with that. So things like strings, they map one-to-one, that's easy. But for other types, you do have to do a little extra legwork to figure it out. It's kind of like writing a TypeScript definition file by hand. I mentioned that, but it's a little more difficult because you have to convert not just between something that doesn't have types and something that does, but something that runs typically in the browser or on Node, and something that typically runs on the JVM and has sort of, originally started with these expectations of running on the JVM. So there's these concepts like, longs that don't make sense in JavaScript land. And you have to figure that out. So I mentioned you can generate types. This, you cannot see like any of that. I'm very sorry. But basically what I'm trying to show here, these are a couple of screenshots from me trying to auto-generate some types for a little library called Chart.js that I mentioned. And most of the green stuff that's kind of blown out on the projector, that's the auto-generated documentation from the ScalablyType project, which, by the way, is excellent, and it is very good. And sometimes it has a little difficulty, and through no fault of its own, mind it. It's actually just because JavaScript is very complicated and very hard to map some things completely. And if you try to have a comprehensive overview of how a library is supposed to work, how these things are supposed to work, then you wind up with these extremely complicated hierarchies of types sometimes, and it's not very fun to deal with. Like, for example, I'm going to just read aloud what's on the right side of the screen, because I don't know how many of you can actually read that. What happened is, so in Chart.js, there is this idea of a chart type. You want to say, I have a pie chart, or a line chart, or a bar chart, or one of these other types of chart types, and that determines the logic of some things. The way that normally works in JavaScript, because JavaScript is a language that doesn't really have fine hierarchies of types like that you commonly use, is you would just pass a string. So a string that says bar or a string that says pi. And then that's actually literally what I do in my code is I pass a string that says pi. But what it was trying to do for generating this is it figured, okay, so it could be one of these string literals. I'm going to collect all these string literals and put them in another package, and you go in there and you find out yourself which one you want. So you have, let's say if I want a pie chart, I have to go to typings.chartjs.chartjs_strings.py. It's a little weird because that's not where it is in the JavaScript library. That's something that it made up on its own because it's trying to organize everything in this standard way across all of the different libraries that it tries to compile stuff for. The other ones in the corner, like the top left corner with the giant green block of text there, there's the chart options that you pass to charts change depending on the type. So depending on a string literal value that you pass in as part of a configuration object, it changes what the possible configuration options are for the rest of the object. It's a mess actually. If I would rewrite the interface for chart.js, I probably wouldn't do it that way. But they do it that way because that's idiomatic in JavaScript. It's not that weird to do something like that in JavaScript. It is very weird to do that in Scala because then you have a million type parameters. And in fact, the TypeScript types for this are actually also very confusing. So this is just trying to parse what TypeScript knows and turn that into Scala. And it's sometimes very ugly. In fact, you can go to the ScalablyType.org encoding docs. I have that linked at the bottom. They have 1.5 million different edge cases and weird things that can happen when you generate, where it's like, oh yeah, this can happen sometimes. And there's like 5 or more examples about things that you can run into along those lines and how to deal with those. There's also some customization options as well if you want to tame it. So here's what I do instead. Every time I've tried to use ScalablyType, I've just given up because it tries to do a lot and it's trying to do something that I think maybe doesn't always work for every sort of project. So in my case, I don't need every single feature of chart.js. I can just make my own types. So I start from the top and I work my way down. I just make my own types in Scala that make sense to me through my own brain. I go, okay, what do I need to make a chart? And I just organize it that way. And then I figure out the translation on my own on the way down. So the high level stuff makes sense. The high level stuff is nice. And you're going to have to write this anyway if you want a good library, whether you're using Scalably or not. If you just use generated types on their own, then you're not going to have this nice idiomatic experience. So I kind of find it better to cut out the middleman, write it yourself. And also, you don't have to do the entire API. That's one thing that saves a lot of time. You still have to write out all that annoying interface boilerplate, but it works to just say, I don't know, if there's a function that accepts up to maybe 20 parameters, and it will work if you just pass in the first 3, and you will only ever use the version where you pass in the first 3, just define the function like that. You don't need to go all the way. You don't need to say the entirety of all of these interfaces in Scala. You can just put in what you need, and it will probably work. In fact, I'm living proof of that because the chart thing just started working right before this presentation. And the other thing, though, that's a big source of difficulty with this. So I want to support dates. Everyone wants to put dates in a database. Well, not everyone, but most people want to have something like a date type, or maybe just support for parsing dates. And JavaScript in the browser notoriously does not have the exact same sort of feature set as Scala on the JVM does with the JDK and the Java time package. So if you've used Scala.js, you've definitely ran into this already. So basically what happens, sometimes you try to compile for Scala.js and then you get a linker error. Most of these happen because you're trying to use a JVM library and you didn't realize that you had one as a dependency of your project. There are ways around this. For example, if you use SBT, there is a wonderful plugin that you can use. I forget the name of it. but it's pretty common. It lets you say, for this project, I want to have a JVM section, a JavaScript section, a native section, maybe even. I think it's the cross project plugin. Someone shout out and correct me on that. Okay, cool. Yeah, that's the one. And that's useful if you have an interface where, let's say, Cat's Effect and Zio do this and stuff like that. You look in their source code, and you will find references to classes and objects referencing the idea of a platform. And that usually refers to the implementation details of things that are platform specific. So if you're trying to do something like a suspend function, like you want to sleep for a certain period of time, you do that a little differently on one platform or another. So like for example, on JavaScript, you can't use blocking APIs ever. It just doesn't work because JavaScript is single threaded by nature. Most of the JavaScript applications out there, they use like an event loop structure. You send events out, maybe you click something on the page or you emit an event, and it just keeps looping and yielding and looping. And blocking doesn't really fit that model. So of course, if you're already using an effect system, that usually takes care of that for you. And that handles those cases because they specifically optimize for allowing your things to run in a non-blocking manner. If they do block, your app will just crash because those APIs just are not implemented because they can't be. Other things that can happen, like binary incompatibility, say you update a dependency or something, or you change something about your project, but then you have some things lying around from other versions. It just gets confused. Just clean your working directory. That's usually fine. But most of the time, it's JVM libraries that cause this issue. Though specifically, I will mention for Java Time, there is at least 1.5 different variants of solutions to this problem, including one that I like, which is just an artifact where you put it in your project and then it pretends to be in the JDK namespace for Java Time, and it's actually a full Scala written implementation of the Java Time namespace. So all of those classes and functions, they all work. Local time, local date, they all work in JavaScript now, and that's cool. And that does require a little manual thing. You just add a single dependency to your project and it works. I didn't bother linking it. You can just Google it yourself. It's like the first result or two. There's like Scala.js Java Time. It's a pretty well solved problem by this point. So now I guess I kind of want to go back into talking about the app itself, because we talked about getting started with Scala.js, the things that have bugged me along the way, and the things that have worked really well. And what works really well the most is actually making apps and making applications. That's what Scala is good at. And we're going to talk about what goes into making this application. So first, let's talk a bit about what I'm trying to do here, making a database, right? So you need a lot of different things. You need a format for storing data. Usually that's like a table. You need some way to define queries or some kind of expression language. You need optimizations for specific use cases. So like, let's say you want to have indexes on tables to speed up queries. That's one thing that you might want to do. And then you need some kind of common interface. Like most databases out there, Postgres, MySQL, you can access them with a million different protocols, not the least of which is JDBC. Not everyone's favorite protocol, but it's there and it works and it's stable. So let's talk about queries. Queries, I have them implemented as using Scala 3 features here. So when you have a query, it's a function from a database, the entire database, to either an error or a result table. And you can chain these queries into each other. So I can say I want to select something, and then I want to select something again, and then I want to filter, then I want to select again after it's filtered. You can do that. The API will let you do that. And the API internally in Scala looks kind of like this. I just have this query object. I can say, I want to query this table, and it will give me that table from the database. And then from there, I can run things like I can filter using an expression. I can select individual columns. I can aggregate. All of these things are implemented in pure Scala using pure Scala types, no JavaScript interop whatsoever. And Scala is just very good at modeling these things because you are able to use all of the myriad of things in the Scala ecosystem. Like for example, I'm actually using the reader monad for this, but I simplified it to make it look like a function here because that's basically the same thing, kind of. And it allows me to just work in a way that's comfortable to me and allows me to model the problem in a way that makes sense. So all of these expressions, all of these different functions, they have those kinds of details along the way. Like right here, I have like right here, Scala 3 type features right here. So query error or a table. I don't necessarily want to be using monadic types everywhere. If I can avoid it, if it's simple enough. So this is a simple case where I say like it's either an error or something else, and then the implementation details figure the details out from there. So expressions, though, on the other hand, I had to write a whole parser. I'm not really going to talk about the parser. It's pretty basic. It's just splitting terms into like a list of strings, and then I loop through the list of strings like that. That's nothing really new. But the expressions are implemented in a kind of similar way to queries. So you have these inputs, and the inputs include the table schema and a row. And most expressions operate on a single row. Aggregations operate on the entire table's rows. So that those are logically separate in the code, and I don't have them defined in the exact same place for that reason. So maybe in the future I'll fix that up. But it works very similarly to the way that queries are defined. So you can have multiple types of expressions. You can just define them arbitrarily. So let's say I have a function that wants to do a less than comparison, and I have an expression. I'm comparing it to another expression. I just recursively resolve the expressions and figure out, is this one a number or not? I mentioned this thing is kind of like a spreadsheet. Everything is parsed all the time. It's super inefficient, but it works. And what it's trying to do is for every single function, every single expression you're trying to do, if it fits a certain shape, if it walks like a duck, talks like a duck, it's a duck. And if you have a string that could be, in theory, a number, then it's a number for all intents and purposes. And you can run functions that require numbers in here. There's no actual type checking on the Scala end because that's all done at runtime. That's the whole point. You run a query, you want to know what happened. So this is basically compiling these expressions and running them, or interpreting them rather. Well, kind of the same thing. Writing a database is a lot like writing any kind of app, really. I went side ahead. Writing a database is a lot like writing any kind of app in a certain way, except you have a lot more general purpose business logic going on, and it makes it a lot more abstract. Most of server-side apps I've ever written are just really glorified interfaces to a database, right? Some of them aren't. Some of them are. A good number of them are. And a lot of the time you're going to be doing these aggregations and filterings and things along the way. So writing a database in this sense is really just taking that problem and trying to make it as generally applicable as possible. And you're going to need to be parsing inputs. You're going to need to be storing data and figuring out a common format of that and building a platform for people to use. And part of this, so I wanted this to run in the browser, right? So I need some kind of state management. I need some kind of user interface. So I'm using this library called Tyrian. And Tyrian is one of a million different Scala.js frameworks and libraries for defining front-end UI and state, mostly state, because the UI part's pretty easy. You could just, but there's a million and a half other libraries for that too, including Scala tags, which was one of the first ones I ever used, which just renders raw HTML. But Tyrian, on the other hand, is very opinionated. It uses what is either something very similar to or basically the Elm architecture, which I'll get into on another slide. And it has a whole bunch of helpers to get you building web apps in a functional, reactive way using Scala idioms. So it's pure FP from the start. It's actually built on Cat's effect, but they don't really require that you know a lot about it to get started. It tries to hide as much of that as possible and keep as much of the goodies, the stuff that you want. Like, let's say I want to focus an element by ID. That's pretty easy. You don't need to understand how the runtime gets there. You just need to understand that it can do that. You can subscribe to arbitrary events. Like if you click a thing with an ID, then that's a stream. You can turn random streams from FS2 into event subscriptions as well. You can also do server-side rendering. because it's Scala, you can run it, well, not just because it's Scala. You can do this with JavaScript too. What am I saying? But you can run a lot of this stuff in multiple different contexts. So you can build pretty much anything you want. This is probably best compared to Laminar, which is another one that gets mentioned very often. Actually, before I used Tyrian, I mostly used React. And there's also a lot of very good Scala.js React libraries, one of which is literally called Scala.js React. And that one has been around for many, many years, and I'm a very big fan of it, actually. But I decided to use Tyrian for this project because along the way in building this thing and reinventing it over the years and trying to come up with an idea of what this would actually look like, I went through a lot of different tech changes. So originally I started with Scala.js React, and I had like a Play app on the back end, and I was trying to do something way more complicated than just a database. And somewhere along the line, I'd said, you know what, I can do the web UI stuff myself. And I decided to try and do it myself and see how far I got. And what I ended up writing was something that used FS2, the streaming library, for state management. And I had like an event loop kind of that I created myself, and all of these events that would emit from functions on things, they would get propagated back up to that loop. It would re-render the page, and Tyrian is almost exactly the kind of thing that I basically wrote myself. So I took one look at it, and I'm like, yeah, okay, these people get it. They did almost exactly what I figured out how to do on my own all those years ago. So I'm just using this now. I'd rather not maintain that, right? So this is kind of the main loop of how it works. So you have at the very top there, you have a little ball of state, and this state is this one big ball, and all of your other state is inside this state. So let's say you have say 5 or 6 different forms that you want to keep the state for. You want to have, in my case, I have tables. I want to keep those tables somewhere. I want to figure out what table is currently selected, things of that nature. Those are all in one big case class. And if I want to drill down into specific ones, then I have little sub-states inside of that bigger state. The HTML for the web page is rendered straight from that state. It's a function from the state to HTML. And that HTML can emit messages. Those messages are usually triggered from some user input, and that message gets sent back up to the top of the loop, and then the state is modified with that message. So let's say I click that button to run a query or something. That's going to send a message that says, okay, you have the current state of the query form. Take what's in that query form and figure out if it's valid or not. If it's not valid, print an error message on the screen. If it is valid, close the form and create a new table that's the result of the query. And all of this logic is done separately from rendering the page, separately from all of that. There's no sort of component structure whatsoever. It's just you have your state that renders all of your HTML, and then all of your HTML emits messages. There's one big block in the middle here for commands as well, and that's for asynchronous tasks that don't necessarily fit in that loop. So say you want to make an HTTP request to some API somewhere. There's helpers for that, or you can do it yourself, and you fit it inside of this idea of like a command interface that runs asynchronously, and at the end of that command, it also emits an event, a message, rather. And these messages are constantly being emitted for a million different things. The browser's efficient enough to be able to handle that. There's no such thing as a virtual DOM in Tyrian, if you are familiar with that. But it gets around that by being functional reactive in style. It doesn't really concern itself with that kind of way of writing web apps. You model things in this way, and the browser figures out, what's the most efficient way to re-render what you're trying to do. And usually it's pretty good about that. And I've been pretty happy with that result, actually. So when you're making a Tyrian app, it kind of looks like this from the start. You have this your main class here. You have a function to update the model. You get that's actually wrong. M is supposed to be a message. So right here, where it says wrong one. Where it says def update. That's supposed to be a that is the model. So it's a function from a message to a message. let me start over. Okay, this is correct, actually. The update function is a function from a message. So let's say I have this message A here and a message B. For the message B, I want to run this set here. It's going to return a new model, and I just fill out whatever I'm supposed to do to change the model from point A to point B. And I return a tuple of that and any commands I want to run. So that's usually pretty straightforward, and your app is basically going to be built almost entirely like this. I'm leaving out the HTML rendering stuff because it goes just about as you'd expect. You take the model and you pass it to a function. It spits out some HTML. That's essentially it. And then you have handlers for saying, oh, when you click this, emit this message. When this changes, emit this message. You can kind of imagine how it works, because I am running a little low on time. I wouldn't have enough time to talk about that. But so this future feature work, there's all kinds of things that I wanted to do that I wasn't able to do in time, but they will be in here eventually. I want to have more custom column formats. I want to be able to say, if you have a value in a column, that it should be able to format a certain way, like say a date, for example. You want to be able to have a date formatted a certain way, maybe ISO format. I want to have remote storage, so you can store your tables and your database somewhere else, maybe a GitHub account, or maybe your Dropbox. It would be nice to just be able to pick it up from my phone, grab it, don't need to think about syncing anything. It just pulls it right from the storage, do my work, save it, it's done. More charts. I only have pie charts right now, and I only have support for like 3 entries, so it'll be arbitrary eventually. And then grid style views is one thing I really want to do. Spreadsheets are really useful at just having lots of different things on one page. And I want to be able to have a view where you say, I want to have this table and that table and maybe this chart over here all in one like dynamic responsive grid. And that would be really nice to be able to do from a user interface standpoint. And then I would also like to extend it a bit so you can maybe use it on the server or maybe use it somewhere else. I don't know why you would use this on the server. Just use something actually better than this. This is made for just human use. If you try and use this for a program, you're probably wasting your time because it's not very efficient. It's not very efficient at doing that job. But if you're just, doing like some basic secretary housekeeping work, you're organizing your video game backlog like I am, then this is probably just fine. Unless you have millions and millions of rows, it's not going to be a problem. And there is a website. Go to tinydb.app and see what's there. There is a little sign-up sheet, actually, to get updates and early beta access. And one more thing. Okay, so it is Pride Month. That's a pretty big deal. I'm not exactly celebrating, but I know a lot of people who are, and they're very important parts of my life. So to encourage everyone to maybe sign up in case you were kind of on the fence, if you sign up and you put in the little secret code box, trans rights, no spaces, then I will donate $10 to the Trevor Project in your honor. I will also run this again once this talk is public. So once this runs again, I'll try and figure out when that is, and 1 month from that day, when the video is uploaded to YouTube or whatever. The Trevor Project, if you don't know, they do suicide prevention for LGBT youth and other things like that. And that's basically all I have for today for this talk, and I'd like to open up for questions.